This video is going to explore how to draw Bohr-Rutherford diagrams. You can see in this cool image, the model of the atom has changed over the years. We're going to focus in on the Bohr-Rutherford. And basically, the Bohr-Rutherford looks like this. You have a nucleus with protons, positive charges, and neutrons, no charge particles, inside. Around the nucleus, you've got energy levels, rings, shells, or orbits, all the same thing, with negatively charged electrons. How do you draw one of these? Well, you need the periodic table in order to help you. And so we're zooming in on the atom of fluorine, and I'm going to walk you through. So, first thing you need to do is find the atomic number. Atomic number is equal to the number of protons. And then you will know that the number of protons equals the number of electrons. So 9 protons, 9 electrons. That's if it's neutral or has no charge. The neutrons, you take the atomic mass, you round it, and you subtract the number of protons. And so that would give us 10 neutrons. Okay, so I've done the hardest part. I figured out the protons, I figured out the electrons, and I figured out the neutrons. Next, I need to draw the nucleus. Here's a nucleus. And I need to put inside the number of protons, which is 9, and the number of neutrons, which is 10. Excellent. All right, I've done those steps all together. Next one, I need to draw the first ring, and I need to put a maximum of 2 electrons in there. So I will do that. Little circles. I will draw the next ring. Do my best here. Okay. And I will proceed to put in electrons. I can put a maximum of 8, but I only have 7 left because I had 9. I used 2. That leaves me with 7. So here we go. 1, 2, 3, 4, 5, 6, and 7. And that is my Bohr-Rutherford for fluorine. And I've done all of these other parts. Okay, I'm going to go on and I'm going to try another one. Sodium. First step, I need to figure out the protons. So I know protons will be 11 because that's the atomic number. I know electrons will be 11 because protons equal electrons. And then I know that I'm going to have this number here rounded to 23. And I'm going to subtract 11 to figure out my number of neutrons. So according to my math, that should be 12. Easy. So far I've figured out the protons, figured out the electrons, figured out the neutrons. My next step, you guessed it, I need to draw a nucleus. My nucleus, I put the protons of 11, neutrons of 12. Okay, it's not so great, but I think it'll be okay. And then I have done that. I've put my protons in, my neutrons. Next, I need to add in my first energy level. Energy level. There it is. It can take a maximum of how many electrons? 2. That's right. There we go. My 2 electrons. So that's that. I'm going to draw my second energy level or shell or ring or orbit. And I can see here that it can take up to 8 electrons. So let's do it. I've used 2. I have 11 total. So that leaves me 9. So I'm going to start placing them. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, but wait, I have 1 left. That means I need to draw 1 more energy level, or ring, or shell, or orbit, because I have 1 more electron to give me the total of 11. And that is my Bohr-Rutherford for the sodium atom.